Okay, everybody, so today we're going to talk about isotopes. And isotopes are when you have an element that has the same number of protons and electrons, but can have varying numbers of neutrons. And so there's a couple things that I want to start talking about. The first one is that protons are always constant. Okay, the number of protons are always constant. This appears 3 times in your notes, and it appears 3 times because it's really important. If you have an element, any element, and say hydrogen, for example, hydrogen has 1 proton. Hydrogen will always have 1 proton no matter what. If you add a proton to it, you now have helium. It's no longer hydrogen. So keeping that in mind is super important. But the number of neutrons and electrons can vary without changing the identity of an element. Electrons can vary, but we're going to hit those in Unit 3, so we're not even going to talk about that at the moment. But we are going to talk about neutrons. And so neutrons are going to be the big thing that's changing here. Once again, the purpose of a proton is to determine the identity of an element. If you add or take away protons from something, it becomes a different element. So let's do a quick review. How many protons, electrons, and neutrons does aluminum have? So I'm going to give you a moment to find aluminum. And so with protons, you should have gotten what number? 13, right? Electrons have 13, right? Because protons and electrons go together. And then your neutrons, you're going to take the mass number of aluminum, subtract your number of protons, and then you get your number of neutrons. To go forward with that, right, now that we know how to do that, you guys mastered that yesterday. An isotope is where we're going to go now. So isotopes are a form of an element that has a different number of neutrons than normal. So that also makes the mass number different. So if you're changing your number of neutrons, your mass number is going to change. Because if you remember, your mass number is the number of protons plus the number of neutrons. Once again, number of protons do not change about an isotope. But yesterday, a couple of you were asking about mass number and atomic mass because you were like, oh, what's the mass number and what's the atomic mass? And why are there 2 different numbers? So this is where this comes in. Your mass number is your exact count for your element you're looking at. It's the number of protons plus the number of neutrons. So for example, aluminum has a mass number of 27. That means that it's going to have 13 neutrons and then, or 13 protons, and then how many neutrons? It should have about 14, right? Now your atomic mass is what you actually see on the periodic table, and that's the one with the decimal. And so an atomic mass is a weighted average mass for all isotopes. So every single isotope every single element on the periodic table has an isotope. And that isotope can be a million different combinations, right? For carbon, you have carbon 12, you have carbon 13, carbon 14, carbon 16. All of those exist naturally in nature. So what they do is they take all of these different isotopes and they average them out, just kind of like we average your grades. So for example, you have 50% of your grade are tests and transfer tasks, 30% are labs and quizzes, 10% classwork, and a 10% final. So we take all of those grades and we average them out based on how much they're worth. And that same thing is happening here with atomic mass. There is more carbon-12 than anything else, other carbons in this world that we live in, right? Carbon-12 is the big number. So if you look at its mass is really close, its atomic mass is really close to 12. You would round that to 12. So that kind of shows you that the most common number for carbon would be 12. Okay, so all isotopes are written like what you see on the screen now, which is carbon with a -12. That means an isotope of carbon has a mass number of 12. Remember, mass number is protons plus neutrons. So let's take a look at how many protons and neutrons are in chromium-58. So go ahead and take a moment. Chromium is Cr. Okay. So if we look at chromium, it's going to have 24 protons, and you know that because of the little number in the corner, that atomic number. And then it's going to have 34 neutrons because what we did was we took 58, which is the mass number, subtracted the protons, and then that left you with 34 neutrons. Chromium-68, it's still chromium, right? It's still going to have the same number of protons, but you're going to have a different number of neutrons. So in this one, you have 24 protons again, and then you have 44 neutrons, because the difference is you've gained some neutrons there. Remember, if I change the number of protons, I'm changing the identity of the element. It is no longer chromium if I were to change that. And then just as a little a forward fact, I can't speak today, sorry. We are going to actually talk a lot more about this towards the end of this unit. But any element that is considered to be radioactive is an element that has an unstable number of neutrons. So if you remember your notes from Monday, you took some notes and it talked about how electrons are going to determine the behavior of an atom, how protons are going to determine the identity of the atom, and then neutrons are going to identify how to stabilize an atom. And so every single element likes to have a certain ratio of protons to neutrons in order to be stable. And so if there are too many neutrons or too few neutrons, the element will undergo radioactive decay to become a more stable atom. But we'll talk about that later, so you don't have to stress about that idea at the moment. One last thing that I want to talk about with your notes, the one periodic table notation to your left, that's the one that you guys saw, and those are the ones you see on the periodic table, right? In the upper right-hand corner, you have the atomic number, your letter is your symbol, and then your atomic mass is at the bottom, because remember, atomic mass is an average. But when you're looking at isotope notation, which is to the right, your mass number is going to go on top, so we don't do anything with atomic mass. We're only looking at mass number, protons and neutrons. Your element symbol is big on the side, and then your atomic number is going to be smaller at the bottom. Now, one thing that kind of confuses people, there isn't a line between 12 and 6. That's just the arrow pointing towards the C, so you're not going to put a line in between there. So what I want you to do now is I want you to pause, and I want you to try and do the isotope notation problems at the bottom of your notes. And then when you're ready to go, we're going to hit play, and then you're going to get to see your answers. Okay, so this is what you should have gotten. And then beryllium, it's 9/4, and the carbon is 12/6, because I know those were hard to come through. But remember, you're always putting your mass number at the top and your atomic number at the bottom. So for lithium, for example, lithium-7 has a mass number of 7 and an atomic number of 3. Lithium-6 has a mass number of 6, atomic number of 3. Same atomic number, same number of protons, different number of neutrons. Okay, so now go ahead. You're going to go and start practicing this on the back of your notes. And when you're done with that, you'll come get another worksheet to do some more practice.